Hey guys, I'm going to walk you through the addition rule for probability tutorial. I'm going to skip over these first couple slides. I'm going to go right to slide 4. You can read all this stuff at the top if you want, but it's talking about roulette, which is another casino game. What's really important here to note is that roulette has a bunch of numbered slots, and what they do is they drop a ball in it, and it's going to land in one of those numbers, and then you win based on your bet. Here's what to know. They have numbers 0, double 0 to 36. Numbers 1 through 36 are either red or black, and 0 and double 0 are green. Okay, so actually this picture right here is not an American roulette because there's no double 0 on there. But that's just kind of describing what roulette is. This was a little story you can read if you want. I'm going to skip over it. And so, hey, here's that roulette table along with, well, there's the wheel, and this is the table where you make your bet. So, this is just as a reminder what mutually exclusive events are. As always, they have these articles that you can read if you want to. But basically, what mutually exclusive events are, if you remember from last tutorial, are events that cannot occur simultaneously. So you can't land on number 1 and number 2 in roulette. So it can't happen. Let's just move on and we'll get to this activity and then kind of make a little bit more sense. So here is a better picture here of the roulette board, and there's a close-up of the wheel. This is an American one. So for this question, what they want us to do is say, okay, the 9 numbers that Jagger and his accomplices, this is the story that we didn't read, identified as occurring more frequently were these 9 numbers. Are these mutually exclusive if the wheel is spun? Remember, mutually exclusive means they cannot both occur. So in this case, I would say yes, because you can only roll one number at a time. Let's check the work. And yes, yay, we got it. Okay. Number 2, they want to know, you can place bets, lots of different bets at roulette. You can bet on a color, whether it's going to be either red or black. And then, so let's just say we're looking at red and we want to see the probability of it being red. Now the roulette table goes up to the number 36. So you might be tempted to say that there are 36 possible things that it could land on, but that is not the case, okay, because you have the number 0 and double 0. So actually, let's just make a note that there are 38 total outcomes. I can't think. Okay, so there's 38 total outcomes on a roulette wheel. If we want to count the number of red ones, you can either count on the wheel or on the table. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I was touching my screen. I know you can't do that. But hey, if you count, the numbers 1 through 36 are either red or black, half are red, half are black. So there are 18 red. So the probability of getting red would be 18 over 38. You can reduce that if you want, but I'm just going to kind of leave it as is just for the sake of time. That would reduce to 9 over 19. Okay. Number 3, another bet you could do is even or odd, and it doesn't include 0 or 0. Again, there are 38 possible outcomes. So if I want to do the probability of it being an odd number, well, again, I have numbers 1 through 36. Half of them are odd, so that'll be 18 of them are going to be odd, divided by the 38 total possibilities. So again, that actually probability of landing on red is actually the same probability of landing on an odd. For number 4, you have to, E1, the first thing they want you to do is the outcome is a red, and the second event is that the outcome is an odd. They want you to list all of these outcomes. It's going to take a long time. But hey, you could look up here and you could list all the red ones, 1, 3, 5, 7, 9, 12, 14, 16, 18, so on and so forth. You could list all of them. The odd ones are pretty easy to list too, but just again, in the interest of time, I'm going to say, hey, here's that list right here. Those are all of the red ones, because E sub 1 is red, and then here are all of the odd ones. Okay, so you can easily list those out. Now, I want it to be E sub 1 and E sub 2. So what that means is red and odd. I want to know which ones are both. So I'd come up here, you can look either at the wheel or the table. I think it's easier at the table. You look 1, 3, 5, 7, 9 are red and odd. None there. Okay, 19, 21, 23, 25, 27. And that's it. So you could list all of those out. Now, where we at right here? Okay, you could list all of those out, and that would be 1, 3, 5, 7, 9, 19, 21, 23, 25, 27. You can double check that. 1, 3, 5, 7, 9, 19, 21, 23, 25, 27. Good. We have found all of the ones that are red and odd. Are they mutually exclusive? And the answer is no, because if we are able to find ones that are both red and odd, then they are not mutually exclusive. Okay. And that's what it says right here, not mutually exclusive, because it could be both. Self-evaluation, give yourself a 5, a high five, and let's move on. Okay. So that's the first one. And even if you don't know anything about roulette, it's really just counting up possibilities on the board and on the wheel. Next, we have to figure out, are they mutually exclusive using that same wheel? So can a number be 1 to 12 and red? Well, yes, it could. So those are not mutually exclusive. Could a number be 1 through 12 and 25 to 36? That is no. So that would be mutually exclusive. Could a number be 1 to 18 and odd? Well, yes, because it could be 1, and that is odd. Can it be black and red? That is no. So those are not mutually exclusive. Can it be even and black? Well, yeah, that could. So that's not mutually exclusive. So let's see how we did. Good. Okay, so remember, mutually exclusive basically means they cannot both happen. So if they could both happen, they are not mutually exclusive. Here's a multiple choice. Suppose Jagger has his bet on a special category that includes any number from 19 to 36. What's the probability of that happening? Now remember, again, on a roulette wheel, there are 38 total possibilities. So I can actually kind of, I did not mean to do that. Let me go back and reload that. But anything that has a 36 on the bottom, I can kind of cross those off because I know that there are 38 total possibilities. So I need to figure out how many numbers are there from 19 to 36. You can count on your fingers if you want, or you could just say, hey, 19 to 36 is all of the first 36 numbers except the first 18. So that means you're going to have 18 left over. Okay? Or you could again count on your numbers, 19, 20, 21. Okay, count on your fingers, and you figure out that there are 18 numbers between 19 and 36. Okay, then we talk about mutually exclusive events a little bit more. In a Venn diagram, it means the two would not overlap at all. Okay, when you flip a coin, you either get heads or tails. It can't be both. When you're playing at like a basketball game, or they have an example of a championship, only one team wins, both teams can't win. Those are examples where you only have one outcome. You only have two outcomes. Another one they talk about here is that you roll a number that's less than 3. It's either 1 or 2, or you roll a number greater than 2 but less than 5. That's either 3 or 4. Those are mutually exclusive. Now, one thing they want you to be careful of is mutually exclusive does not mean the probability is going to add up to 1. And in the case of the dice, that is what happens. Okay, so that's kind of what they're saying there. If they are not mutually exclusive, they're going to look like this, where they have that little overlap. And that's where we need to account for that and subtract that from the probability so that we don't double count anything. And that's kind of what all this stuff is saying. At this activity, E sub 1 is red and E sub 2 is odd. So I'm going to actually kind of write that in my table here. Just as a reminder. What they want you to do is actually list out all of the values in this table. I don't feel like doing that right now. But all the red ones are 1, 3, 5, 7, 9. You could list them all out. All the odd ones also, you could easily list them out. Now, E1 and E2 are red and odd. And if I'm looking at that table, I can fill these in. And those are all the ones that are red and odd. Okay, so I want to know this S minus, that is basically S minus all of this. So basically everything that is not red and not odd. Everything that's not red and not odd is basically the black even ones to start with. 2, 4, 6, 8, 20, 22, 24, 26, 28. But let's not also forget that you could also have 0 and double 0, and those are green, but they are definitely not red. So let me just kind of double check those. Again, I didn't list all of these ones out here, but you can see that you are more than welcome to do so. So now for question number 2, the probability of E sub 1, remember it's the probability of red. We had said earlier there were 18 red options and there were 38 total red choices. Probability of E sub 2 is the probability that it's being odd. And again, if you count up, there are 18 odd numbers and 38 total possibilities. So the probability that it can be both, well, if you look at this table up here, E1 and E2, that's red and odd. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 options there. So that means that probability is going to be 10 out of 38. Okay? And so we can double check those answers, and yeah, we're good. Okay. Now this, don't get freaked out by that notation. This is basically saying what is the probability that it is red or odd. Now when we have an odd statement, if these are mutually exclusive, which they are, they do overlap. What we need to do is find the probability of red plus the probability of odd, and then subtract the probability of red and odd. Okay, so this will be the probability of red. There are 18 red slots, there's 18 odd slots, and there's 10 that are red and odd. So 36 minus 10 is going to give you 26 total possibilities for it to be red or odd out of 38 total. 26 out of 38, that's my final answer right there. Okay, so don't let that notation freak you out. Compared to the Venn diagram, does it match? It sure does. Number 5, consider an experiment with a playing deck. You have 52 cards. We've talked about this before. The first event is going to be red, and the second event is whether it's a face card. So I want to know the probability of red or face card. And now, are these mutually exclusive? Yes, they are, because it can be red and a face card. So we're going to find the probability of red, which is 18. For face cards, there's 3 face cards in each suit. There's 4 suits, so there's 12 possible, 3 times 4, there's 12 possible face cards. Now, however, we have to subtract the probability of it being red and a face card. Come back. Which, if I just keep going here, red and a face card, well, half of the face cards are going to be red because we have the hearts and the diamonds. So then that would be minus 6. So then if I add those up, it's going to give me, and then subtract the 6, it's going to give me 32 out of 52 total possibilities. And then they reduced it to 8 over 13. Number 6, I want to know the probability that it is an ace or a king. Now, these are not mutually exclusive because they don't overlap. So I just need to add up the number of aces, which is 4, the number of kings, which is 4. I don't need to subtract anything because they don't overlap at all. And so this will give me 8 out of 52 for my probability, which I would reduce to 2 over 13. Okay. Then finally, number 7, I want to know the probability that a card is a 10 or a spade. And now for 10 or spade, there are 4 10s, there are 13 spades, but they do have some overlap. There are 10 of spades is in both of those, so I have to subtract 1. So if I do 4 plus 13 is 17, minus 1 is 16, divided by the total 52. My probability of 16 over 52. Okay? And so, hey, we really did that one great. I'm going to give myself a 5, and I'm going to keep on going. This next one is a multiple choice. And so they say the probability of rain is 0.72. The probability that the temperature will be greater than 75 is 0.84. And then it will probability of rain and greater than 75 is 0.64. What's the probability that it's rain or? So I actually already worked this out. So again, sorry for the mess over here. But the probability of rain is 0.72. Probability that it's greater than 75 is 0.84. But then I have to subtract that overlap, that minus 0.64. Which if you work that out in your handy dandy calculator, will give you a probability of 0.92. Okay, this one just talks about some real world applications. We'll come back to that. Here in this activity, if you read this, basically the community wants to build either a soccer field or a pool, maybe both, maybe none. We're going to fill in some probabilities from reading here. Here it says the probability that they would support a soccer complex or a swimming pool is 0.95. I fill that in. The probability of wanting the soccer complex is 0.6, and then we can read further, the probability of the swimming pool is also 0.6. Right, now they don't tell us the probability that they would support neither, but if I know how many people would support either one of those, that means whatever's left over, so if 95% of the people support one or the other, that means 5% or 0.05 would support neither. Because you would do 1 minus 0.95. So that would 0.95, and that would give you 0.05. So if we just double check our answers, yeah, that's right. What is the percentage of the population that wanted both of them? Okay, so I know I don't see a swimming pool and soccer field. So what I'm going to have to do is I'm going to have to add up their individual probabilities, 0.6 plus 0.6. And then what I'm going to do, if I were to use that addition rule, I would say at this point it's going to be minus the ones who want both. And I know that the or population is 0.95, so this would equal 0.95. Okay, because that's how many people would support either one. But if I want to find out how many would support both, I would basically just solve that equation, which would be 0.6 plus 0.6 minus 0.95 would equal the people who wanted both. And if you do that, you end up getting, let me work this out real quick, 0.25. So 25% of the people wanted both, which we can see here. Now, question 3 says, what percentage of the population was opposed to building both? Now, this is not that 0.05 from up here. 0.05 is people that wanted neither. Okay? This is asking how many people didn't want both. So here, this 25% or 0.25, that's the probability of people that wanted both. That means if I do 1 minus that, that's going to give me the people who didn't want both, which would be 0.75, sorry. And let's check that answer, which is correct. And then for question 4, does this value agree with the recall petition? If you look here, it says 75% of the people did not want both. So then yes, this did agree with the recall, which is what they say down here. Okay, 5. Great job. And then this next one, this is just another example, another real world example where they work everything out for you. You are more than welcome to read through that yourself. But just in the interest of time, I'm going to skip that. And then here's a summary. And we finished it. Okay, so hopefully this helps you out. If you have any further questions, let me know and I will gladly help you.